Hey guys, today we're going to take a look at finding slope from a graph. So first we need to understand what is slope. Well, slope is simply the steepness of a line. And in general, there are four types of slopes that we see. So first of all, if it looks like you're climbing up a hill from left to right, that is a positive slope. So this line has a positive slope. Look at the second graph. If your line goes down from left to right, looks like you're rolling down a hill, that line has a negative slope. So that's the second type of steepness or slope that I want you to be familiar with. Then look at the third one. Notice that line, it's just a plain old horizontal line. It's almost like you can sit something on top of it. So if you see that line, a line that looks like that line has a zero slope. So if it says, what's the slope of that line? Well, it's zero. And then let's take a look at the final line. This line looks like a wall. It's a vertical line. And this type of line has something called an undefined slope. So those are our four basic types of slope. Well, now let's take a look at some graphs. We can actually calculate or find the steepness of a line by using this formula or this relationship. M, which stands for slope. Think about a mountain, montor. It's Latin for to climb. So to find the slope, we write the ratio, the change in y over the change in x. And I'll show you how to calculate or how to find that in just a second. You'll also hear it called rise over run. So I want you to remember or memorize this relationship. To find the steepness of a line, we take the ratio of the rise over the run. And we usually write that as a fraction, a simplified fraction, or if it can be reduced to a whole number. So here's how you actually calculate the slope of a line. I like to start off by finding two corner points. And if you look in example 1, they were nice enough to find that for us. So I see, when I talk about a corner point, I mean a precise or an exact point on the line where it crosses the corner of the grid. Those are just easier to help us calculate. Then I draw a triangle. It doesn't matter which direction you go, but you always want to go up or down first and then to the right. And then I simply count the boxes. Now make sure that you look at what each line or each space is worth. That's called the scale. So these count by ones. So I rise 1, 2, and I run 1, 2, 3. So my slope, rise 2, run 3, and it's positive because the line is increasing from left to right. So let's try a few more. Take a look at number 2. So first I want to find two really good corner points. And I notice there's a good one here at negative 16, and there's another really good one at 0, 14. So now I draw my line up or down just to get to the second point, and then side to side. That's rise over run. Remember, look at your scale. I rise 2 and I run. See, the x also counts by 2, so 2, 4. And that will simplify by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. And I notice that this line decreases. It's a negative line, so my slope is negative 1/2. Let's keep going. Take a look at number 3. Now, I could very easily calculate this one, or I can use what I learned earlier. This is an undefined slope, but I want to show you what that looks like if you do your rise over run. It does not matter which two corner points you choose. So I do my rise, but I don't have a run. So I rise, looks like each one is 2.5. So 2.5, and I run 0. Well, in nature, you can't take something and divide it by 0. That's how I understand if the zero's on the bottom, that is an undefined slope. Let's look at example 4. So first I want to start by choosing 2 really good, clean corner points. This looks like a good corner point. That looks like a good corner point. So now I'm going to do my rise and my run. Make sure you look at your scale, and it looks like each of these are counting by 1. So I rise 1, 2, and I run 1, 2, 3, 4, 5. So my slope is 2/5, and it's positive. It's increasing from left to right. I want to show you something on this example. Excuse me. Here's how you know you got it right. If I can rise 2 and run 5 and touch the line again, I know I have the right slope. 1, 2, 3, 4, 5. There it is. Because here's the thing. Slope is constant. So I want you to write that down. Slope is constant. That means that no matter what 2 points you choose on the graph, they will simplify to the same exact reduced fraction. So let's try number 5 and test that theory again. So I see a good corner point here, and I see another corner point right here. And I look at my scale. Well, first let me draw my rise and my run. Looks like each one of these go up by 2s. My rise goes up 2, 4, and my run, they seem to go up by 1. So this is 1, 2, 3. So my slope is 4/3, and it's positive because it's an increasing line. Let me test my slope. Rise 1 or 2, 4, run 1, 2, 3, and it looks like if I increase that line or lengthen that line, it matches up. So I know I found the right slope. So now let's talk about something called rate of change. So when you have a real situation or a real world situation, you can still find the slope of a graph. But what's going to happen is it's called rate of change. So let's look at an example of this. So Terica is dissolving a substance in a solution for a chemistry experiment. Terica measured the amount of substance remaining in grams over time passed in seconds. The linear relationship is shown on the graph. The fact that it says linear means the slope is constant. Find the rate, here it is, find the rate of change of the grams remaining with respect to time. So here's what they do. They tell you grams with respect to time. Grams, that's your rise. Time, that's your run. See, change in y over change in x. So I'm going to find my 2 corner points. You do it the same way, guys. It's just called rate of change, and they give you words with it for your x and your y axis. So they were nice, and they gave me 2 points, my 2 corner points. So I'm going to draw in my rise and my run. And if you're doing this on the computer, of course you won't draw, but it'll work the same way. Now I notice my rise, my y goes up by 5s. So this is, my rise is 5, 10, 15, 20. And my run, now my x goes up by 1s. So this is 1, 2, 3. So my slope is 20 over 3. Now here's the deal. Typically if it's just a graph, we'll leave it as a fraction. But if it's a real world situation, you can divide that and get the decimal. So you can either leave it as 20 over 3 grams per 3 seconds, or I'm going to divide it. And I'm going to do 20 divided by 3 is approximately 6.6 repeating grams per second. So that's how you do rate of change in a real world situation. So let's try another one. So number 7. it says, a snow machine makes snow from blocks of ice. The linear relationship, that means constant, relationship between inches of snow and blocks of ice is shown on the graph below. Find the rate of change of inches of snow per blocks of ice. That's your rise over run. Snow, inches of snow per blocks of ice. So let's do our rise over run, or our change in y over change in x. So first I want to find two really good corner points. Well, I like that they gave us 0, 0. That's a good one. This is not a good one. It's not a corner point. Nope, nope. That is a beautiful corner point. So now I'm going to draw my rise and my run. So now I'm going to draw my rise and my run, and I notice my rise goes up 2, so 2, 4, 6. And my run also, my x's go up by 2s, so 2, 4. So my slope is 6 over 4. Now I could reduce that. Oh, that's not approximate if I reduce it. If I'm going to leave it as a fraction, I can divide each of those by 2 and get 3 over 2 inches of snow per 2 blocks of ice. Or remember, I can also divide and I get 1.5 inches per block. And I want to go back and correct something on number 6. On number 6, what did we forget, or what did I forget? That line is decreasing. It's going down, so my slope should be negative 20 over 3 grams per 3 seconds, or negative 6 6/10 grams per second. So take your time, use your notes to help you in your practice, and I'll talk to you guys soon.